Morning, students. Welcome to another session on probability and statistics for data analysis. Yesterday, try to pull up a slide. Yeah. Yesterday, we looked at learning outcome 1, which is develop understanding of distribution theory. And then today, we will be looking at learning outcome 2, which is develop understanding of classical interface. So these are the indicative contents. We have impression statistics, a point estimates, an interval estimate, a credible interval, descriptive statistics, on univariate analysis, bivariate and multivariate analysis, degree of models, full parametric, semi-parametric, non-parametric, p-value, confidence interval, null hypothesis, significance testing. So, as usual, we have a video again to watch. So,
not all oranges are the same. That's why we pick the best 4 varieties for that taste, for that juice.
Give me a sec.
Tropicana.
So we'll be watching this video at the end of the class. So the video will tell us more about understanding the statistical inference. And so yeah, so we have 2 types of statistics. We looked at this a little bit yesterday. So we have descriptive statistics, we have impression statistics. So what is descriptive statistics? This is a method used to describe and understand the features of a specific data set by giving short summaries about the sample and the measure of the data. So obviously, like the name says, this descriptive. So obviously, like there's a description or there's a short summary about the sample and measures of the data. So we have 2 categories. Measure of central tendency. We have 2 categories. Measure of central tendency, measure of variable spread. And then in this image, we have the main median mode, which are the measures of center. So statistical measures that represent the summary of a data set, average value of the sample. Also, we have measures of variability. So yeah, so the first one is measure of central tendency. Second one is measure of variability spread. So it is used to describe the variability in a sample or population. So we have the measure of spread, we have the range, we have the interquartile range, the variance, and standard deviation. So what is measure of shape and distribution? Skewness indicates the asymmetric of the distribution. Kurtosis measures the bigness or flatness of the distribution. So let's go back and obviously like check what measures of variable is. You can literally check a variability. I mean, not variable. Yeah, so yeah, like we said, we have the range, interquartile variance, standard deviation. So you can read more about it on here. So this is the example of descriptive statistics. So variability refers to how how spread scores and the distribution out. That is, it refers to the amount of spread of the scores around the mean. For example, distribution within the same mean can have different amounts of variation or dispersion. So you can check the histograms of quiz 1 scores and also quiz 2. So this is score range and everything. So you can see the range, the interquartile range, variance, standard deviation, and all. So yeah. Percentile and quartiles. So Yeah. Percentile represent the values below which a certain percentage of data falls. That's what percentile means. So yeah, so that's what it is. And so we have quartiles, which divide the data into 4 equal parts, each contain 25% of the data. So we have count, frequency, and proportion. So what is count? The total number of observations in the data set. That's what count is. We have frequency, which is obviously like the number of times a specific value appears in a data set. So take, for example, like you have a data set and you have loads of twos in it. So the frequency, the frequency is how many times two occurs in that data set. We have proportions, the relative frequencies or proportion of different values in the data set. We have inferential statistics. This is a branch of statistics that deals with forming inferential predictions about the population based on a sample data collected from the population. All this can be seen online here. So inferential statistics, this will be used to compare the difference between the treatment groups. Inferential statistics use measurement from the sample of such subjects in the experiment to compare the treatment groups and make generalization about the large population of subjects. There are many types of inferential statistics, and each is appropriate for a specific research design and sample characteristics. So we have point estimation. Point estimation is concerned with the use of the sample data to measure a single value, which serves as an approximate value or the best estimate of an unknown population parameter. So right here, we have interval estimates. An interval or range of values used to estimate a population parameter is called interval estimate. So we have the point estimate, we have the low confidence limit, and then between the low confidence limit and the upper confidence limit, we have the interval estimate. So that's what the interval estimate is. So confidence interval. Confidence interval is a measure of your confidence that the interval estimate contains the population mean. And also, we have statistics. We also know that statisticians use a confidence interval to describe the amount of uncertainty associated with a sample estimate of a population parameter. Technically, a range of value so constructed that there is a specified probability of including the true value parameter within it. More about this can be found online. So what does this website say? This website says that confidence interval is the mean of your estimate plus or minus the variation in that estimate. This is the range of values you expect your estimate to fall between if you do your test within a certain level of confidence. So confidence in statistics is another way to describe probability. So yeah. We have margin error. So margin of error E for a given level of confidence is the greatest possible distance between the point of summation and the value of the parameter it is estimating. We also have hypothesis testing. Formulating a hypothesis. The hypothesis is a statement or assumption about a population parameter. Example, we have mean and proportion that we want to test or investigate. So my bad. Hypothesis testing statistics. So this is a clear definition of what hypothesis testing is. So this website says hypothesis testing refers to a statistical process that helps researchers determine the reliability of a study by using a well-formulated hypothesis and set of statistical tests, individuals or business can make inferences about the population that they are studying and draw conclusions based on the data presented. So we have all this, and then and literally look at So a few example, a teacher assumes that 60% of his questions come from lower middle class family. So obviously we can use this formula to test it, and obviously I know how it works. And then we have two types of hypothesis: null hypothesis and alternate hypothesis, among other things. So what are the steps of hypothesis testing? We have step one: specify your null and alternate hypothesis, gather data, conduct a statistical test, determine rejection of your null hypothesis, and then finally represent your results. Those are the steps of hypothesis. Those are the steps of hypothesis testing. So we have sampling. This is selecting a representative sample from the population of interest. The sample should be chosen in such a way that it reflects the diversity and characteristics of the population. So take, for example, you want to know about you want to do weather forecast. You have to like go back to getting the sample, and then you can use the sample to know how to forecast the weather. So sampling. So this is what it means. In a statistical study, the sampling method refers to how we select members from the population to be in study. And then, so we have all this, and then these are the sample. And you can just from there, you can just remove someone from there, just for the sample. And data collection. Gathering data from the selected sample using appropriate research methods, such as surveys, experiments, or observations. Because that's what data collection is. And we have different types of ways that we can collect data. Yeah, we have 4 types. We have primary data collection methods, and then we have secondary data collection methods. And obviously the primary involves quantitative method and qualitative methods. The quantitative methods involve survey, polls, among other things. And then the secondary data collections, obviously, you source data from secondary places, which can be magazines, sales report, times, software, among other things. So next topic is inferential statistics technique. So we have confidence intervals. What is that? Estimating the range within which the true population parameter is likely to fall. We have hypothesis testing, assessing the likelihood of observing the sample data if the null hypothesis is true. So obviously we looked at what hypothesis testing is, and then we saw null hypothesis and everything. We have regression analysis, examining the relationship between variables and predicting outcomes based on the observed data. We have analysis of variance, ANOVA, which means comparing means across multiple groups to determine if there are significant differences. We have chi-square test, and analyzing categorical data to determine if there's a significant association or difference between variables. Next, we'll be looking at how to draw conclusions. So obviously, like based on everything that you've done, the hypothesis and everything, the methods that you used, you have to like draw a conclusion. So like, as you can see, it means based on the result of the statistical analysis, drawing a conclusion about the population and making generalization or prediction. That's literally what we do there. And then we just don't draw conclusion. We have to like look out. Yeah. So you have a data, and then obviously like you use all the statistical method for it, and then lastly you want to draw a conclusion. You have to obviously find a way to report and write it. Next, we'll be looking at assess how inferential statistical analysis is different from descriptive statistics. What is descriptive statistics? Like the name says, descriptive statistics involve the analysis and summary of data in a way that describes and presents its main features. It focuses on organizing, summarizing, and presenting data in a meaningful way to gain insight and understand patterns within the data set. Descriptive statistics provide measures such as mean, median, mode, standard deviation, range, and percentiles, which help to describe the central tendency, variability, and distribution of the data. The goal of descriptive statistics is to provide a concise summary of the data set and facilitate an understanding of its characteristics. So that's what descriptive statistics is. Obviously, like you have the mean and everything, mean, median, mode, among other things. So take for example, right now, you have a class of students, and then you want to find the mean, median, or mode of students that can score, the students that have scored below 60% or students that have scored above 60%. So that is what descriptive statistics is all about. And then we have inferential statistical analysis. What does that mean? Inferential statistics, on the other hand, involves making inferences and generalization about the population based on a sample of data. We've looked at what sample of data is, and we've looked at this in the previous slides. It utilizes probability theory and sampling techniques to draw conclusions or make predictions about a larger population based on the observed sample. The goal of inferential statistics is to make statements or test hypotheses about the population parameters using sample statistics. It involves estimating parameters, testing hypotheses, and determining the level of confidence or certainty associated with the results. So take, for example, the example that I gave before. You want to like predict the weather of an area. You can't just do that. You have to like make some tests. You have to run some tests. So they are just like proof, and you doing that is obviously like you testing the hypothesis. So that's what inferential statistical analysis is all about. And then what are the key differences? First of all, the purpose. Descriptive statistics aims to summarize and describe data, whereas inferential statistics focus on drawing conclusions or making predictions about a population based on a sample. So, like I said, this descriptive statistics is usually all about summarizing and describing the data, where inferential is usually just making predictions and all based on the sample data that we have, or based on the type of other information that will be given. So moving on, we have population versus sample. So descriptive statistics describe characteristics of the observed data, while inferential statistics use sample data to make inferences about a larger population. Generalization. Descriptive statistics provide information about the observed data, but inferential statistics enable generalizations and predictions beyond the observed data to the larger population. Probability and uncertainty. Inferential statistics heavily relies on probability theory and measures uncertainty through confidence intervals and hypothesis testing. Whereas descriptive statistics primarily focuses on presenting the observed data without incorporating probability concept. Moving on. So give me a sec. Let me see this. Couldn't see it properly. Yeah. Okay. Let me minimize it again because I couldn't see clearly. Distinguishing between three levels of modeling assumptions. So we have distribution assumptions, which refers to assumptions about the probability distribution of the data. They define the shape and characteristics of the distribution from which the data is assumed to be drawn. Common distributional assumptions include 1, normality, multinomial, and exponential. So what is normality? Assuming that the data follows a normal Gaussian distribution, which we looked at yesterday. Give me a sec. Yeah. So we looked at what. Yeah. So obviously, like this is what normal distribution means. Bell curve and every, which means bell curve. So yeah. So assuming that the data follows a normal Gaussian distribution, as maybe it has the bell curve, this assumption is often made in parametric statistical models. We have multinomial. Assuming that the data follows a multinomial distribution, which is appropriate for categorical data with multiple categories. Exponential, which is assuming that the data follows an exponential distribution, which is commonly used for modeling time to event data. So we have independence assumptions. What does independence assumption mean? This relates to the relationship between observations or variables in the data. They assume that the observations are independent of each other or that there's systematic relationship between variables. Common independence assumption include number 1, independence of observation, and then independence of errors. What is independence of observation? Assuming that the observations are independent of each other, meaning that the value of one observation does not influence the value of another. That's what independence of observation is. And secondly, independence of error, assuming that errors or residuals in a regression model are independent of each other, indicating that there's no correlation or pattern in the residuals. In continuation, we have linearity assumptions. And then what is linearity assumptions? So this means this assumption pertains to the relationship between variables in a model. They assume that the relationship between variables can be adequately described by linear relationships. And then example of common linearity assumptions include linear regression, which we looked at yesterday, assuming that the relationship between the predictor variables and the response variable in the regression model is linear. Additivity, assuming that the effects of different predictors on the response variable are additive, meaning that the combined impact is a simple sum of individual effects. So we have discussed frequentist inference with example. We have hypothesis testing. We've looked at this previously, and then we are looking at it in detail again. So this is a fundamental concept in frequent inference. It involves testing a null hypothesis. That's literally what it is about, against an alternative hypothesis to make a decision about the population parameter. So you have a null hypothesis, and you want to test it against the alternative hypothesis. That's what hypothesis testing is. And then we have an example. Suppose we want to test whether a new drug has a significant effect on lowering blood pressure. Obviously, before we do that, we have to know the null hypothesis and we have to know the alternative hypothesis. So in continuation, the null hypothesis might be that the drug has no effect. That's what the null hypothesis is. That obviously, like maybe the drug does not have any effect. And the alternative hypothesis would be that the drug does have effect. So we have the null hypothesis does not have effect, and the alternative hypothesis, it has effect. So you have to make a test of the two. Through data analysis and statistical tests, such as a t-test or a chi-square test, we can access the evidence in the sample to make a decision about accepting or rejecting the null hypothesis. We have the maximum likelihood estimation, which is MLE. Maximum likelihood estimation is a method used to estimate the parameters of a statistical model by maximizing the likelihood function. The likelihood function measures the probability of observing the given data under different parameter values. The parameter values that maximize the likelihood are considered the most likely estimates. For instance, in logistic regression, MLE is used to estimate the coefficient that best fit the observed data and predict the probability of a binary outcome. So today we have the references. So these are the books, articles, and journals that we use. So the first book is Hypothesis Testing and Model. And then we use Introduction to Robust Estimation and Hypothesis Testing, which is an academic press. And then we use hypothesis testing, survival analysis techniques for censored and recorded data. And also, thank you for listening today. Don't forget to send us an email if you have a query, and obviously send us an email if you want to submit your assignment. So let's go back to the video and then conclude the class for today.
Statistics Learning Center presents Understanding Statistical Inference. Hi, I'm Dr. Nick, and in this video, I'm going to explain what statistical inference is. Statistical analysis has two main focuses: descriptive statistics and inferential statistics. Descriptive statistics summarize data using graphs and summary values such as the mean and interquartile range. Descriptive statistics can help us identify relationships and patterns. Descriptive statistics do not draw conclusions beyond the data we already have. Inferential statistical analysis does allow us to make conclusions beyond the data we have to the population from which it was drawn. A definition of inference is the process of drawing conclusions about population parameters based on a sample taken from the population. The sample is the data we collect from the population. Here are some examples of populations and samples. The population is all the apples in an orchard. A sample is 100 apples we pick from the orchard. The population is all the chocolate bars we produce on a machine. A sample is the 30 bars we choose to melt down and weigh the nuts from. The population is all the voters in New Zealand. A sample is 1,000 people who are asked their opinion in an online survey. In each of these examples, we can use the data from our sample to draw some conclusions about the objects or people in the population. For example, we want to know about the weights of the apples in the orchard, so we take a sample of apples and weigh them and use that information to draw conclusions about the weights of apples in the whole orchard. There are three main ideas underlying inference. A sample is likely to be a good representation of the population. There is an element of uncertainty as to how well the sample represents the population, and the way the sample is taken matters. First, it is reasonable to expect that a sample of objects from a population will represent the population. If our orchard has only red apples of a fairly consistent size, then we would expect the sample to contain red apples of a fairly consistent size. If our machine is producing chocolate bars with a percentage of nuts within a certain range, then we would expect the sample to also have nuts within that range. If 40% of the people in New Zealand believe that the economy is getting worse, then about 40% of the sample will also believe that. Second, there is an element of uncertainty as to how well the sample represents the population. A sample will never be a perfect representation of the population from which it is drawn. This is the reason for sampling error. We have a video about sampling error. Nor will all the samples drawn from the same population be the same. But through simulation and probability theory, we can get an idea of what the population is likely to be like from the information the sample gives us. For example, let us assume that 40% of the population of New Zealand think the economy is getting worse. If we took a sample of 1,000 people, how likely is it that 50% or more of them will say that they think the economy is getting worse? We can work this out using probability theory, or we can run a simulation on a computer to see what we would expect from a whole lot of samples of size 1,000 taken from a population with 40% thinking the economy is getting worse. This graph is the result of a simulation with 1,000 samples of 1,000 people each, drawn from a population with a proportion of success of 0.4 or 40%. We define success as being that the person thinks the economy is getting worse. It turns out that if the true proportion in the population is 40%, the probability of getting a sample with 50% or more people saying that they think the economy is getting worse is 0. It won't happen. Just about always, the sample proportion will be within about 3% of the population proportion when we use a sample size of 1,000. That 3% is called the margin of error. It can be used to create confidence intervals. Confidence intervals give a range within which we think the population parameter is likely to be. You can see more about confidence intervals in our video, Understanding Confidence Intervals. In inferential statistics, we can also test hypotheses. Our videos, Understanding the P-value and Hypothesis Testing, explain these. The third principle is the way the sample is taken matters. This principle relates to non-sampling error, which we also have a video about. The sample must be representative of the population, and this happens best when each person or thing in the population has an equal chance of being selected in the sample. In natural or manufacturing processes, we may be able to take random samples reasonably easily. However, when our population consists of people, this can be more difficult and costly, so we do the best we can. We explain this further in our video on sampling methods. This video has been about sample to population inference. We are interested in what the sample tells us about the population. It is not about causation, which is covered in other videos. This video was brought to you by Statistics Learning Centre. Visit our website for more resources to help you learn.
Oh, that's the video. And then let's make a recap on what we've looked at today. So, yeah, we looked at learning outcome 2, which is develop understanding of statistical inferences. And then these are the indicative contents that we looked at today. We looked at what hypothesis is, looked at null hypothesis, among other things. So, yeah, that's all for today. Hope to see you next weekend. Thank you.